Hello guys, we are going to prefer solutions to the CHM101 practical questions and answer. Please make sure that you have your pen and your book to follow through the class. Don't just copy. Understand the concepts so that if you are asked, you'll be able to reproduce them. So we are going to start with the exercise 5 and then we are going to take the first question. Now make sure that you subscribe to this channel, turn on the notification button so that you'll be notified whenever we post a new video. The first question here says calculate A, the number of moles of H2SO4 and B, the number of grams of H2SO4 in 500 milliliter of 0.324 mole of H2SO4 solution. Now before we solve this question, we should write the equation that is required or the formula required to solve this question. Now we are going to use the formula of molarity. Molarity, the formula is equal to number of moles all over the volume either in liter or in dm³. Molarity is equal to the number of moles all over the volume either in liter or in dm³. Now the first question says we should calculate our number of moles. So from molarity, if we make number of moles severe to the formula, what are we going to have? Number of moles times 1 will give us what? Number of moles. And this will be equal to the molarity times the volume. Of course, you know that this is part A of the question. Now we ought to write out our molarity given. Now the molarity given is 0.324 molar and then the volume is equal to 500 milliliter. Now this 500 milliliter, because most times our reference standard is usually 1000 milliliter, which is 1 liter. All what we are going to do is to divide this by 1000 to convert to liter. So if you are given your volume in milliliter, you should try as much as possible to convert it to liter by dividing by 1000. So when this divide this, is going to give us 0.5 liter. So our volume is equal to 0.5 liter and our molarity is 0.324 mole. So our number of moles. Now what did we say was our number of moles? The number of moles is the molarity times the volume. So what we are going to do now is to substitute in and then see what it gives to us. What is our molarity? 0.324 times, where is our volume? Our volume is 0.5 liter. Of course, we know that this is let's put in our unit. This is molar, which is the same thing as mole per liter, then times 0.5 liter. So our number of moles would be equal to, when these two multiply each other, what are you going to have? 0.324 times 0.5 is going to give us 0.162 mole. So this is our number of moles, 0.162 moles. And then the part B says calculate the number of grams or the number of grams of H2SO4, the grams of H2SO4. So our number of moles is equal to 0.162 moles. Let's see if that is correct. That's our number of moles, 0.162 mole. So what will be our answers in gram? Now note that number of moles formula is equal to mass over molar mass. So our mass in gram will be equals to number of moles times the molar mass. Now, why is it like that? because this is number of moles. If we say this over 1, then cross multiply. When this multiply this, it gives us number of moles times what? Molar mass. Then mass times 1 will give us what? The mass. So now what is the molar mass? The molar mass is the sum of the atomic masses of all constituent atoms. So in H2SO4, we are going to sum all of them together and see what it gives to us. Hydrogen is 1 times 2 plus sulfur, I think is around 32, plus oxygen is 16, so 16 times 4, and this gives us 2 plus 32 plus 16 times 4 is 64. So when you add everything here together, what is it going to give to us? 2 plus 32 plus 64 is going to give us 98 gram per mole. So the molar mass of H2SO4 is 98 gram per mole. So our mass now in gram will be equals to number of moles 0.162 moles times the molar mass 98 gram per moles. Now mole or per mole rather, mole cancel mole, and then our mass in gram will be equals to, when you multiply this and this together, what is going to give to us? This times 0.162, and that will give us 15.876 gram. So this is our answer to this particular question. So our mass in gram is equals to 15.876 gram. Let's take the next question. The next question says calculate the volumes in liters and in milliliter of a 0.324 molar H2SO4 required to completely react with 2.792 gram of sodium triazocarbonate according to the equation. Now the equation given to you is this. Now how do we calculate the volume in liters and milliliters? The question says according to the equation, so we must take cognizance of the equation. Now how many moles of H2SO4? So you are given this number 2 question. Calculate the volume in liters and milliliters of a 0.324 H2SO4 required to react completely with 2.792 gram of sodium triazocarbonate according to the equation. Now the equation given to you is this. Now from the equation, you agree with me that 1 mole of H2SO4 is equivalent to 1 mole of sodium triazocarbonate. Are you getting it now? So what do we do? If 1 mole is equals to this, it means that the number of moles of sodium triazocarbonate must also be equal to the number of moles of H2SO4. But in the question, you're not giving the number of moles of H2SO4. You're not also giving the number of moles of this. But you can easily calculate the number of moles of sodium triazocarbonate using these 2 data here. Now, how do we go about calculating the number of moles of sodium triazocarbonate? Now, note fully well that molarity is what? From our understanding, molarity is, or let's say number of moles. Let's take sodium triazocarbonate first. Number of moles of sodium triazocarbonate is equals to the mass all over what? The molar mass. Now let us talk about the mass of molar mass of sodium triazocarbonate first. What is the molar mass? Sodium is 23. How many are there? 2 plus carbon is 12 plus oxygen is 16 times 3, which is 46 plus 12 plus 48. 46 plus 12 plus 48 is what? 106 gram per mole. Are you getting it now? So the molar mass of sodium triazocarbonate is 106 gram per mole. Now the mass given in the question is what? 2.792 gram. Divided by the molar mass is 106 gram per mole. Now when you punch this in your calculator, it's going to give us 2.792 rather divided by 106 going to give us 0.0263 moles. So the number of moles of H2SO4 now from the given mass is 0.0263. Now this mole must also be equivalent to the number of moles of H2SO4. Why? Because you have the ratio as 1:1. So the number of moles reacting here must be equal to the number of moles reacting here. So the number of moles of 0.0263 must also be equal to the number of moles of this other one here. But you don't know the volume. So how do we calculate the volume? You cannot say that since the two are equal, we can say also that, let's go to the next slide. So we have 0.0263 of sodium triazocarbonate must be equals to number of moles, since the moles are molar ratio are the same, of what? H2SO4. So how do we calculate for the number of moles of H2SO4? It's very easy. Now we know that molarity is what? Number of moles, let's say number of moles all over volume. So the number of moles, was it known? No. So our number of moles will be what? Molarity times what? Volume. So what will be our number of moles now? Molarity is 0.324 times volume. Volume is what you are looking for, so you don't need to substitute in. So in place of number of moles of H2SO4, now we can now put this entire expression here, and that will give us 0.0263 sodium triazocarbonate would be equal to 0.324 times the volume you are looking for of H2SO4. So to get the volume, divide both side by this, divide both side by this. So when this cancels this, our volume will be equals to 0.0263 divided by 0.324, and that will give us, when you calculate this with your calculator, it's going to give us 0.0263 divided by 0.324. It's going to give us 0.081, let's say, in liters. So this is the volume in liters that it's going to give to us. Now let me come here and convert this to milliliter. How do you convert this to milliliter? 0.081 liter to milliliter. What do you do? Divide by, multiply by what? 1000. So if you multiply this by 1000, it's going to give us 81.2 milliliter, and this is the answer. So the answer in liter is 0.08, and the answer in milliliter is 81.2 milliliter, and that is the solution to that question. Let's go to the next. The next question says, find the volume in liters and milliliters of a 0.50 molar sodium hydroxide solution required to react with this H2SO4 according to the equation. Now let's use the equation for neutralization, which is CaVa all over CbVb is equal to Na all over Nb, where Na and Nb are the molar ratios of the acid and the base. Ca is the concentration of the acid, V is the volume of the acid, Cb is concentration of the base, and Vb is the what? Volume of base. So if we are to substitute in values now, what is it going to give to us? Find the volume in liters and milliliters of a 0.505 molar sodium hydroxide. It means our Cb, which is the concentration of sodium hydroxide, is given as 0.505 molar sodium hydroxide. What about Vb? Vb, was Vb given? No, the volume is what we are asked to find. Required to react with 40, it means that our Va was given, which is 40 what? Milliliter, and Ca concentration is also 0.0505 mole. Now our Na, concentration of acid, is 1, and our NB, concentration of the base, is 2. Now this is the acid, H2SO4 is 1 mole here. This is the base, sodium hydroxide, is 2 mole here. That is why Na is 1 and NB is what? 2. Now substituting into this equation, what are you now going to have? You are going to have our Ca is 0.0505, Va is 40 milliliter. Of course, you should take note of that. Cb is also 0.05. Okay, Cb is this is not 0.05 but 0.50. Okay, let's take note. So this is 0.505, this is 0.505 times Vb is unknown, equals to Na is 1 and Nb is 2. So when you solve, what is this going to give to us? Now, of course, you know that this can cancel out this. Are you getting it? So you are left with 40 all over Vb. 40 is in mole, is equals to 1 all over 2. Cross multiply. When this multiply by this, Vb, which is Vb times 1 is Vb, is equals to 2 times 40 milliliter. And then your Vb is equals to 80 milliliter. So the answer in milliliter is 80 milliliter. Now in liters, converting from milliliters to liter, it will now be what? 80 divided by 1000. And that will give us 0.088 liters, and that is the solution to that question. Let's take the next question. How many milliliters of 18 points is still the same thing? So our Ca is 18.0 mole of H2SO4. So Va is what? Unknown. Are required to prepare 1 liter. So the new concentration, this one now is dilution. So let's use M1 as the initial concentration and V1 as the initial volume, and then M2, the final concentration, is 0.90 mole, and then V2 is 1 liter. So from the equation of dilution, which is M1 V1 is equals to what? M2 V2. How many milliliters of 8.0 mole H2SO4? 18.0 rather. So this becomes 18 times our volume is unknown, is equal to M2 is now the new molarity, 0.9 times the new volume is what? 1 liter. Of course, note that the volume is in liters because that's what you are asked to find. So if we use this as V1, our V1 now will be equals to 0.90 times 1 divided by what? 18. If you use this 18 to divide both sides, and then V1 will be equals to 0.9 divided by 18, and that will give us 0.05 liter. So V1 will be equals to, in milliliter, now what do you do? Multiply by 1000. So this will give us 50 milliliter, and that is the solution to that question, 50 milliliter. Let's take the next question. The next question says, calculate the mass of nickel sulfate contained in 20 grams of a 6.0% solution of nickel sulfate. Now, percentage, when you say calculate the mass of nickel sulfate, percentage is, you can give it as let's use the formula, percentage by mass. Let me use this formula, percentage by mass, depending on whether mass by mass or mass by volume, by mass is equal to the mass of substance all over mass of solution times 100%, which is 100 over 100. So when they give 100 times 100%, so now in this case they gave you the percentage as what? 60. So we can say 60% means what? 60 over 100. Okay, this is 6.0, not 60. So this 6.0 all over 100 is equal to, where's the mass given? The mass is 20 gram all over. The mass of solution is not. Calculate the mass of nickel sulfate contained in 20 gram of a 6.0% solution of nickel sulfate. Calculate the mass of nickel sulfate contained in 20 gram of a 6.0% solution of nickel sulfate. Now, I believe there's another question here. A 6.0 contains 40 grams of nickel, so calculate the mass of the solution. Okay, this one they say calculate the mass of nickel sulfate. So it means that the mass of substance is what you are looking for, X, contained in 20 grams of a 6.0% solution of nickel sulfate. So the mass of solution in this case is what? 20 grams. Are we getting it now? So times, of course, 100% means 100 over 100. Now at the end of the day, when this cancels this, it gives you 1. So you are left with 6 all over 100 is equal to X all over 20. Now when you cross multiply, this gives us 6 times 20 is equals to 100x. Divide both side by 100. Divide both side by 100. When this cancels this, and this will now give us 12 divided by 10 is equals to x. Then this cancel this, your x is equals to 1.2 gram. And that makes sense, because if you press it to your calculator, 1.2 gram divided by 20, that is 100%. Let's see if it will give us 6%. 1.2 gram divided by 20 times 100 give us 6%. So that will give us 6%. So your answer is 1.2 gram of nickel sulfate. Are you getting it now? So that is solution to that one. Now, a 6.0% nickel sulfate solution contains 4 grams of nickel sulfate. Calculate the mass of the solution. A 6.0%. Now, the formula I gave initially was what? Percent by mass is equal to mass of substance all over mass of solution times 100%. So in this case now, the percentage by mass was given as 6%. So 6% will be equals to, what's the mass of substance? Said a 6.0 nickel solution contains 40.0 gram of nickel. So it means the mass of nickel is 40.0. Calculate the mass of the solution. The mass of the solution is not known. Times 100%. Of course, 6% means what? 6 over 100. This equals to 40 gram all over S times, then we have 100% means 100 over 100. 100 over 100 cancel. This gives us 1. Then we have 6 over 100 is equals to 40 all over S. Cross multiply. This 6 times S will give us 6x is equal to 100 times 40. And this will give us 6s is equals to 4,000. Divide both sides by 6. X will be equals to 4,000 divided by 6. And that gives us 666.66, which is approximately 666.7 gram. So the mass of the nickel solution is 666.7 gram. That is the solution to that question. Let's look at the next. The next question says calculate the molarity of a solution that contains 3.5 gram 3.65 gram of HCl in 2 liter of solution. Now, what is the formula I gave for molarity? I said molarity is number of moles all over volume. Now, what is the number of moles? Now, we said number of moles is equal to mass over molar mass. So if number of moles is equals to mass over molar mass, what will now be the number of moles? In this case, the mass is 3.65 gram. The molar mass of HCl is what? Hydrogen is 1 plus chlorine is 35.5, and this gives us 36.5 gram. So this gives us 36.5 gram. Are you getting it now? So the molar mass will be equals to 3.65 divided by 36.5 gram, and that gives us number of moles, rather 0.1 mole. So the number of mole is 0.1 mole. So our molarity now will now be equals to number of moles is already given as 0.1 mole divided by 2 liter solution. So you say 2 liter. Are you getting it now? So our molarity in this case would be equals to 0.1 divided by 2 is 0.05 mole per liter, or you can just say 0.5 molar solution. 0.5 molar solution. So that is how to go about this particular question. Let's take the next. The next, a sample of commercial sulfuric acid is 94% sulfuric acid by mass, and its specific gravity is 1.84. Calculate the molarity of the acid. Now, molarity is equal to the number of moles. Molarity when specific gravity is given is equal to, in this case, our molarity would be equal to the specific gravity get out, times percentage purity times the percentage purity times 1000 divided by the molecular weight So what is that going to give to us? Our molarity would be equal to, the specific gravity was given as what? 1.84 times the percentage purity is 90 SAS high yield, which is 96.4. What is the problem of this stuff? 96.4 times 1000 divided by the molecular weight. What is the molecular weight of H sulfuric acid? Is H2SO4. That is the molecular weight of sulfuric acid, H2SO4, which is equals to, I think that was 98 we calculated the other time. Let's do it again. This is 1 times 2 plus 32 plus 64. That will give us 32 plus 64 is 96 plus 2 is 98 gram per mole. So this divided by 98 gram per mole. And when you punch this in your calculator, your molarity would be equal to, if you punch this in your calculator, your molarity will be equal to 1.84 times 96.4 times 1000 divided by 98 gram. Wow, this is so big. Let's try it again. This big, like very big. Let's see. This is where the issue is. You are supposed to convert this your percentage purity to fractional form. So the percentage purity is 96.4%, which is 96.4 divided by 100. It was 0.964. So this becomes 0.964 times this, and that will give us, let's say, 1.84 times 0.964 times 1000 divided by 98, and that will give us 18.099 molar, or we can say 18.1 molar solution. And that is the solution to that question. Let's take the next. The next is a very long one. 0. Now you are asked to calculate the percentage composition by mass of HNO3. Now what is the molecular weight of HNO3? Hydrogen is 1, nitrogen is 14, and oxygen is 16 times 3. This will be 1 plus 14 plus 48, and that will give us 1 plus 14 plus 48. That will give us 63. So this is 63 gram per mole. Now percentage by mass of hydrogen will be equals to the mass of hydrogen divided by the total mass, which is 1 divided by 63 times 100%, and that will be 1 divided by 63 times 100, which is very low, 1.59% approximately. That of nitrogen will be, nitrogen there is 14 divided by 63 times 100%, and this will be equals to 14 divided by 63. That will give us 22.22%. Of course, you know the other one will be for oxygen. So oxygen will be equals to, how many oxygens are there? 48 divided by 63 times 100%, and that will be 48 divided by 63 times 100%. This will give us 76.19, which is approximately 76.2%. So the percentage of hydrogen here, 1.59%, oxygen is 22.22%, and that of oxygen is 76.2%. And that is the solution to that question. So let us solve this question. The question says that a 0.1014 gram of purified glucose was burned in a carbon-hydrogen combustion train to produce 0.14 gram of CO2 and 0.0609 of H2O. An elemental analysis showed that glucose contained carbon, hydrogen, and oxygen only. Determine the mass of carbon, hydrogen, and oxygen in the sample and the percentage of these elements in the glucose. If the molecular weight of glucose is 180, determine its simplest formula and the molecular formula. Now this question is about 4 questions in one. Let us provide solution to it. Now the first thing we need to know is the mass of glucose. The mass of glucose, which is the mass of sample. So we can say that the mass of glucose is, it was given as 0.1014. So the mass of glucose is 0.1014 gram. That's the mass of glucose. Now the next thing that was given was the mass of CO2. Mass of CO2 is 0.148. So we come here and say mass of CO2 equals to 0.148 0.148 gram, and then mass of H2O is equal to, this one was given as 0.0609, so we have it as 0.0609 gram. So these were the things that we are given. Then we are given the molecular weight of glucose. So we come here and say molecular weight of glucose is 108 or 180 atomic mass unit. Now how do we solve? Now for us to calculate, the first question says determine the masses of carbon, hydrogen and oxygen in the sample. We need to determine the mass of each of carbon, hydrogen and what? Oxygen. Now first of all, we need to know the amount of carbon in, or the amount of carbon in carbon dioxide. Now we know that there is one carbon, so we can say there is 1 mole of carbon is present in 1 mole of carbon dioxide. And that 1 mole, what is the gram? We can say that 12 gram approximately is equal to, where's the atomic mass of CO2? I think the atomic mass of CO2 is 44 gram, because CO2 is carbon 12 plus oxygen 16 times 2, which is 12 plus 32, which is what? Approximately 44 gram. So if 12 gram of carbon is present in 44 gram of CO2, therefore 0.148 gram CO2 would be what? X, because you want to know the amount of carbon that is present in CO2. So if you cross multiply, what is this going to give to us? To give us 44x is equal to 12 times 0.148. Divide both sides by 44. 44 cancel 44. Your x is equal to, this will give us 12 times 0.148 divided by 44, and that will give us 0.0403 gram. So the amount of carbon present is 0.0403 gram. Now this is for carbon. Let us talk about the one present for, let us calculate for that of H2O. Where can we find H2O? Is in water. Now what is the mass of hydrogen in water? In water you have 1 molecule of hydrogen, which is 2 hydrogen like this. So we can say H2 is present in H2O. What is the mass here? It will be 2 gram, because 1 times 2 gram will give us 2 gram of hydrogen is present in 18 gram of water. That is relationship. 2 gram of hydrogen is present in 18 gram of what? Water. Therefore, what was the mass of H2O given? 0.0609 gram of H2O would be equal to what? X. At this point in time, you can calculate. So this gives us 18s, if you cross multiply, is equal to 2 times 0.609. And at the end of the day, this will give us X is 2 times 0.609 divided by 18. And that will give us 2 times 0.60. Okay, this is supposed to be 0.0609. 0609. So this is 0.0609 divided by 18, and that will give us 0.00676 gram. So therefore, the mass of hydrogen present in this compound is 0.0676 gram. But you were told that the total sample is 0.1014 and it contains carbon, hydrogen and what? Oxygen. So we can say that carbon plus hydrogen plus oxygen is supposed to give us 0.1014
4 gram. That of carbon is what? What do you calculate for carbon initially? Is 0.0403 plus that of hydrogen is 0.00676 plus oxygen is unknown, is equal to 0.104 gram. Then when you solve this and clean this part, when you solve this, it's going to give you when you solve this, it's going to give you this. So the mass of oxygen, now if you add the first two together, if you add this plus this, what is it going to give to you? 0.0403 plus 0.00676. Now this will give you 0.04706 plus that of oxygen is equal to 0.104. So oxygen is equal to 0.104 minus 0.04706. Now at the end of the day, if you subtract this from this, what is it going to give to you? It's going to give you 0.104 minus 0.04706, and that will give us that of oxygen at 0.0993 gram. So carbon is present as 0.0403 gram. Hydrogen is present as 0.00676 gram, and oxygen as 0.0993 gram. Now the next question says we've calculated the masses of carbon, hydrogen and oxygen in the sample. Say calculate the percentages of these elements in glucose. Now you are asked to calculate the percentages. To calculate the percentage of carbon, what do we do? It's very easy. That of carbon will be the mass of carbon divided by the total mass given, total mass of glucose. Now note that the mass of glucose given in the question is what? 0.104. So percentage of carbon now will be 0.0403 divided by 0.104 times 100%, and that will give us 0.0403 divided by 0.104 times 100. That will give us 38.75%. That is the mass of carbon. Now let's calculate for that of hydrogen. Hydrogen is 0.00676 divided by 0.104 times 100%, and that will give us 0.00676 divided by 0.104 times 100%. This will give us 6.5%. That of oxygen is 0.0993 divided by 0.104 times 100%, and that will give us 0.0993 divided by 0.104 times 100%. No, there's an error in calculation somewhere. Okay, that of oxygen is supposed to give us, it's not supposed to give us that answer. That of oxygen supposed to give us 0.05694, gram. Supposed to give us this answer. Don't know, but preferably that is what it's supposed to give to us. So if you calculate for that of oxygen, when you add this and this together, it's going to give us 0. Okay, let's add. It's going to give us this 0.104 minus 0.04706, and that will give us 0.05694 gram. So here supposed to give us 0.05694. When you divide that 0.05694 divided by 0.104, it's going to give us times 100 is going to give us 54.75. Now if you add everything together, that will give us 100% plus 38.75 plus 6.5 is going to give us 100 on the dot. That was why I shouted no, because if you added that 95 plus everything here, is going to be more than 100. Are we getting it now? So that is the percentage compositions of carbon, hydrogen, and oxygen. Now the next thing is to calculate the empirical formula. Now how do we calculate the empirical formula? We take carbon, hydrogen, and oxygen, bring their percentages, which is 38.75, 6.5, 54.75. At this point, we divide by their atomic masses. Carbon is 12, hydrogen is 1, oxygen is 16. Now when you divide, it's going to give us 38.75 divided by 12. That will give us 3.22. 6.5 divided by 1 is still 6.5. Then 54.75 divided by 16 is going to give us 3.42. Okay, divided by 16 is going to give us 3.42. The first one is 38.75 divided by 12, 3.22, which is 3.3. Now divide both sides by the smallest. The smallest here is 3.22. So when you divide this, it's going to give us, when this cancel this, is going to give us 1. 6.5 divided by 3.22 is going to give us approximately 2, and when this divide is going to give us 1. So the empirical formula is C1H2O1, which is CH2O. Now from here, now we can now calculate the molecular formula. What is the molecular formula? We are told that the molecular formula is the empirical formula bracket what? N will give you the molecular mass. The molecular mass of glucose given initially is what? 180 atomic mass unit. So from here now we can now calculate to get our answer quickly. So what will be our answer now? We said CH2O is the empirical formula bracket N will give you the molecular mass. So carbon is 12. Hydrogen, we are adding the atomic masses. Hydrogen is what? 1 times 2 is 2 plus oxygen is 16. Bracket N is equals to the atomic mass, molecular mass, which is atomic mass also is 180. So at this point in time, 12 plus 2 is what? Is 14. 14 plus 16 is 30. So we can say 30N is equals to 180. Divide both sides by 30. When this cancel this, your N is equal to 6. So it makes sense. If you now substitute into the equation, what you had initially was CH2O bracket what? N. Now your N is 6. So this becomes CH2O bracket 6. Use this to open through, becomes 6 is H12O6, and this is the exact molecular formula of glucose. This is the exact molecular formula of glucose, and this is the answer to this question. Thank you.